We've done some examples of finding domains using graphs. Now we'll find domains using algebra. We'll begin with this example that says square root of 5x minus 10 minus 5 on the outside of the root. Our objective is to find the domain. Here we'll introduce a rule that we call the root rule. For square roots, the inside of the square root must be greater than or equal to 0. The reason for this is if we take a square root of a negative number, we will end up with a complex answer. And when we're dealing with domains, we want only real numbers, not complex numbers. Therefore, we will look only to the inside of the root. The minus 5 on the outside of the root will not affect the domain. We'll box in the inside of the root, 5x minus 10, and we'll say that must be greater than or equal to 0. Then we'll solve for x. We'll begin by adding 10 to both sides. If we add 10 to both sides, 0 plus 10 gives 10, and we'll have 5x is greater than or equal to 10. Then we will divide both sides by 5 to get x by itself. When we divide, we'll end up with x greater than or equal to 10 divided by 5, which is 2. Now we'll draw a number line to try to look for the domain. We'll place the infinities on the left and the right. We'll mark down 2 on this number line. We will also note the symbol in between the x and the 2. If that symbol is greater than or equal or less or equal, you'll use a closed circle. If that symbol is strictly greater, strictly less, or not equal, you'll use open. Since we have greater than or equal to, we will use a closed circle for 2. Also, the symbol will tell us which way our domain lies. If we see greater than or equal or strictly greater, we will say to the right side of the dot is where the domain will lie. If you have less or equal or strictly less, that means to the left is where the domain will lie. Since we have greater or equal, we will fill in the right side of the picture in green. We'll also use an arrow on the right to show that this green region will go on toward infinity. I'll also place red X's through the left side of the picture to show that the left side of this will not be part of the domain. Our solution set, shaded in green, will be from 2 to infinity. Also, since we have a closed dot on 2, we will use a square bracket in that position, and infinity is always parentheses. This is how we find the domain of a square root function. This will be the case anytime you have a square root or any even root. One variation on this problem that you may see is a root with a 3 above it, meaning this is a cube root. However, cube roots are completely unrestricted and will not affect the domain. Only square roots or other even roots will affect the domain. Odd roots will never affect the domain, so if you see a 3rd root, 5th root, or 7th root, or so on, that will have no effect on the domain and will not restrict it. So even though we have a root, because it's an odd root, this will not affect the domain at all, and effectively there are no restrictions on this domain. And if you have no restrictions, your answer is automatically negative infinity to infinity with no need to draw a picture.